Okay, so we're going to rewrite this first one to cosine of theta is equal to -1. Now, does that have any different rules for that than normal cosine problems would?
Yeah, so like the bottom two on the circle are crossed off.
Because you're only allowed to do inverse cosine up here. So these are out. And then how about this cosine is negative? So how does that inform you?
The top right one's crossed off.
Yeah, this one can't work because of the fact that cosine of theta is a negative. So now I know I'm drawing it in here. So I draw my little triangle in here, and then cosine of theta equals -1. Dang, I feel like something's wrong here. Like, are you noticing anything? Like, what's happening? Why is this kind of imploding on me? Yes. Because if I put this over 1, adjacent over hypotenuse, I have a 1 here and I have a 1 here. That's a sign that I must be on a quadrantal. Or this is just impossible. But wait, let's go off to the side and see if it's impossible. You tell me, is cosine ever equal to -1? Think about the graph of cosine. Does cosine ever hit -1? Yeah, it does. So this is not one of those that's like impossible. So it must be at a quadrantal. And I would wager it must be either here or here, on either end of that zone there. Okay, so now let's do this. Let's just draw it again. You don't have to redraw it, but I'm going to redraw it to make it clearer to people that it's either here, which is 0, 1, or it's here, which is -1, 0. Only one of them's got a negative, so we're pretty sure it must be that one. But we'll just define it one more time. Do you remember that cosine is the x? We want the spot where x is -1. That's that spot. That's pi. There's your answer. How many of you figured out that the answer was pi? Put your hand up loud and proud. Oh, only a few people. All right, don't feel bad then, because maybe 1 or 2 online kids and 1 or 2 in the classroom figured that one out. All right, next one. Also, not easy, and I want to get you started because a lot of people don't even know how to start. Would you agree that I can subtract 1 from both sides? We can do that on an equation. So 1 minus 1 is, well, it's just gone. Or you could say it's 0. Minus 2 sine squared theta is equal to -1/2. Next step. You're hurting yourself if you're not writing this down. I see lots of writing on lots of screens. You know what to do next? You got to get rid of the -2. You know what to do?
Yeah,
nice. I'm going to choose to multiply by -1/2, which is like dividing by -2 on the other side. And then I get sine squared theta is equal to 1/4. I hope at this point it kicks in that, oh, I can square root that. Let's get rid of the squared. Sine theta is equal to, I'm going to break it into 2 square roots. There's a lot of things to keep in track of here, but what's the square root of 1? 1. What's the square root of 4? 2. So that's really 1/2, isn't it? Do you get that the square root of 1/4, when you break it up, really turns out to just be 1/2? And if I stopped right here, how many of you made the same mistake that I did? Because something I just did was wrong. Do you see what's wrong? Anybody want to tell me what's wrong? You know what's wrong?
Plus or minus.
Yes. Why? And this is a critical moment. Do you remember that x squared equals 25? You're solving along and you go square root, and the answer isn't just x equals 5? Because your teacher back in the day glossed over this and just said it's plus and minus 5. Get it? It works. But the problem is what really is happening is it's the absolute value. When you square root a variable, it's the absolute value. This is the absolute value of sine is equal to 1/2. And in the end, it brings in what he said, which is you'll end up with a plus and a minus. But that's why. It's because we square rooted a variable. And if you go back to the most simple ones, x squared equals 16, and you square root and you square root, the answer is never x. It's absolute value of x. We should not let people just slap in a plus minus because they don't know why. All right, so anyway, you absolute value that sign. Now I can have two answers. Sine of theta is equal to a half, and sine of theta is equal to negative a half. And was this even an inverse sine question in the first place? Or inverse cosine? No, it was not. Was there a word arc in there? No, there wasn't. So there isn't restrictions. That means there's two answers for this one and two answers for that one, which means there's four answers. The worst ones have 6 answers. Welcome to what I think is one of the hardest units of the whole year, and you're partway through it. Because in this case, there's 4 answers. So everybody take a moment, try to figure out those 4 answers. It's like 2 little circle trick problems. I don't want to bore you. Raise your hand if you're already done with all 4. Okay, try to stay focused. Simplify it down to just getting these 2 and trying to solve them. ASTC. Sign's positive, so it can't be here and it can't be here. This is not an inverse sine question, so I actually have to do both. Sine is opposite of hypotenuse. And that's a 30-degree angle. So then that's pi over 6. So the answer is pi over 6. Well, that's one of the answers. And then over here, I don't have to recreate and reinvent the wheel. I already know it's pi over 6 in here. That's the reference angle. Excellent. I thought for a second I was some surreptitious cell phone use, but I was not. I apologize. So I'm going to now say it's a bunch of pi over 6's, 5 pi over 6. Raise your hand if you had pi over 6 and 5 pi over 6. Virtual hands too. Okay, excellent. Then there's 2 more answers, and same deal. You don't have to reinvent the wheel. Somebody already invented the wheel. You can just copy it. We know that these are pi over 6's. And I know that where sine is negative is in the opposite 2 quadrants, so I can just go, okay, what's the one in here? I don't have to refigure out all the sides. These are pi over 6's. That's pi over 6. So then what's the answer? 7 pi over 6. And then the last one's going to be here. And that's got to also be a pi over 6 right there. So then this is a whole bunch of pi over 6's. 12 minus 1, 11 pi over 6. 7, 11, 5, and 1 pi over 6. There's my 4 answers. Raise your hand if you had all 4. Okay, so I feel like that was great and everything, Mr. Surver, but you kind of walked us through 3/4 of it. So how about if I just give you one more? 2 cosine squared of theta is equal to 1. Solve. Okay, so we'll have a little checkup here. If you're totally getting this, this is going to be no big deal. Can you tell me the first step, sir? Just the first step.
First step.
Trying to get the cosine alone, so.
2.
Yep. 2's gone. Next step, got to get rid of the squared. Do you know it? Same kid.
Oh, square? Yeah, you square root.
Square root. Then, there's the tricky part. Who's got it? Raise your hand if you're confident in this. Don't be scared to raise your hand. Be bold. He's been sick for a week and he can do it. Come on. What do you say?
Then you would, I guess, take the absolute value of cosine theta, and then you would get 1 over square root of 2.
Ooh, I like it. McLaren, he's got it partway there. Now what?
So then what I did was I drew a little.
Can we break it into equations first before we draw the little?
Plus and minus.
All right, so then we need a cosine of theta is equal to 1 over root 2, and we need a cosine of theta is equal to negative 1 over root 2. And remember that negative could be on the bottom. It all depends on where it feels right in the drawing. Okay. All right. Mr. Rosen.
I drew 2 of the graphs and
Were we in the A, S, T, or C? Or you can say 1, 2, 3, or 4.
the A.
Okay. All right. Why only the A?
Because that's where both values are going to be positive. If you have it in the S, you're going to have a -1.
All right. I would agree we can't have an S over here. I agree with that. But wait, isn't there another place where cosine's positive?
You do it in C as well.
You can, yes. So we'll start in 1, but we'll have in quadrant 1, which is the A one. And then we'd also have to do it in C. So then we have a cosine's adjacent over hypotenuse 1 root 2. Let's save some time here. That one's supposed to be a 1. Ooh, I know this one. Do you know this one?
Pi over 4.
Pi over 4. And then don't reinvent the wheel. Jump right to here and know it's a bunch of pi over 4s. Now how many?
7 pi.
7 pi over 4. Those are my first 2 answers. Raise your hand if you got those. Okay, good. Next up, let's go with Bamer to set up this one. Which quadrants am I in? A, S, T, or C? All right. So we need cosine's negative. So there's where it was positive. I agree. I'm drawing my triangle. Cosine's adjacent, hypotenuse, 1, 1, root 2 like that. Oh, again, I don't really need to reinvent the wheel. It's the same base angle of pi over 4. So what do you think those 2 answers are?
I got 3 pi over 4 and 5 pi over 4.
3 pi over 4 and 5 pi over 4. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. 4 answers. Helena.
Would it be okay if we did like negative pi over 4 and negative 3 pi over 4?
Interesting. Is this an inverse trig question?
No.
I think you know the answer to that then. So I know it's confusing. When do you use negatives and when don't you? If you're in the middle of an inverse trig question, you got to use negatives. And the reason that they can burn you on this is the directions are going to say all the answers between 0 and 2 pi. Because do you get these are cyclical? They go up and down and up and down. There's actually infinite answers. If you want to keep going, if you looked at the graph of this, there's going to be an answer that keeps on hitting on the graph over and over and over. So there's infinite answers. So you got to stop. So you say between 0 and 2 pi, and that precludes negatives. That's why. And you never saw those directions, so I can't blame you for that. But know that on the test, the directions will be there, and you always want to do positive answers unless you're doing inverse trig, because we won't have that answer of between 0 and 2 pi on inverse trig. Okay. All right. Let's get to we're not doing more proofs. No, we've done enough torture with that. And this, we just did a problem just like this, so we're going to skip that one. But everybody, look at this one, number 2. Cosine 2x is equal to root 3 over 2. And I did it in a way last time that I kind of regret. I made it more complicated than it needed to be. Now, it could work. We could refine cosine of 2x on the sheet. You know what I mean? Like that's a thing on the sheet, right? And it would be true if we swapped out something else for it. But there's a much easier way, and I'm going to show you that today. Don't even need the sheet for this one. Can you just act like this was just theta? Could we? Well, sure. Can we get the right answer out of doing that? Yes. Because later in the problem, do you remember these substitutions that we would do earlier in the year? We would say, you know what, to make the problem easier, let u equal this. Remember the u substitution? This u substitution way will be a lot easier. And so we're going to go off to the side and let 2x equal u. Why? Because then we could just have one little variable here, u. Cosine of u equals root 3 over 2. And isn't that super easy, actually? It's just a circle trig question. Which is why I kept telling you we got to learn circle trig. Because here we are. We're just thrilled when the problem turns into a circle trig question. So go ahead and solve this as if the problem had said, let u equal root 3 over 2 and solve for u. But then when you're done, you paid, your life was easier because you made this deal. You know what? Let's let this complicated thing be easy. Well, later then, the other side of it, you have to pay the piper. You got to make a problem that looks easy at the end more complicated again. Lila, which ASTCs do you think we're going to be in here? Quadrant 1, 2, 3, or 4?
A and C.
All right, because cosine's positive, you're saying A and C. So I'm going to cross these off, and you are absolutely right. And I'm in this quadrant here, and I've got cosine, which is adjacent, and hypotenuse. Do you recognize the reference angle that we're dealing with here? This guy? Theta?
Is it 30 or 60?
It's 30. Because it's across from the 1, I have that memorized. You should too. When it goes across from the 1, that one's the smallest side, and therefore it must be the smallest angle, and that must be 30, which is also known as pi over 6. How many of you had a pi over 6 as part of your answer? Okay, good. Then there's another answer, and we're not done. We're just kind of partway done. Now I'm going to get the other answer, which is down here. No need to put all the sides on it and everything. We know it's a function of some kind of pi over 6s. Whole bunch of pi over 6s. Oh, must be 11 pi over 6. But write out the answer and say to yourself, oh, so u is the angle. U equals pi over 6, and u equals 11 pi over 6. And whenever you see a u in your answer, you should know you're not done. Because remember, we made it easier by letting u equal this thing. Now we got to swap it back. And u turns back into what it used to be, which was 2x equals pi over 6. And 2x equals 11 pi over 6. And then I have to multiply by a half everywhere. X equals pi over 12, and x equals 11 pi over 12. That was called a u substitution. We took the part that was kind of complicated, and we made it better. And then at the end, when I got my answers, now I had to make it more complicated again and then finish it. Let's see if you really caught that. Sine of 3 theta. Good luck looking that one up on the table or the sheet. But we need to say what it's equal. I'm going to say it equals negative a half. Sine of 3 theta equals negative a half. Do a u substitution. Make your life easier. Just don't forget to pay the price at the end. When you've got a nice easy answer, then you make it more complicated again. So, first off, this should really just become a u. So off to the side, I'm make them more formal. Let u equal 3 theta. So now it's really sine of u equals negative a half. I draw my quadrants A, S, T, C, and sine is negative. And that means that I must be not here and not here. So now I'm going to draw it here. And sine is opposite over hypotenuse. And one's negative. There we go. and then 1, 2, square root of 3, and that's also negative. Most common mistake in circle trig is forgetting the negative there. Now I just got to know what the angle is. The cross from the 1 is a 30. You got to memorize that. Then that's a pi over 6. Then it's 6 pi over 6 plus 1 more is 7 pi over 6. But I'm not done. All right. So far, do you see any mistakes so far? How many of you had a 7 pi over 6 at this point in your problem? Okay, good. Now, there's another answer down in here, and that's like also based on pi over 6s. And that's going to be more pi over 6s. It's not 12 pi over 6, back off 1, it's 11 pi over 6. And now I'm going to remind you that that's u equals. I figured out angle u. Now, because I let u equal 3 theta earlier, I got to let u equal 3 theta. Now, 3 theta equals 7 pi over 6. And then 3 theta equals 11 pi over 6. And divide or multiply by 1/3 on both sides. So that theta is alone 7 pi over 18 and 11 pi over 18. Put your virtual or real hand up if you had that one right. Yay, there's hope for you still. You're gonna have more time to learn this. It's not like the test is tomorrow, okay? But foundational principles here. If it's complicated, make the problem easier by pulling out the complicated part and putting in something like a single variable like u. And then make it like, oh, then it's just a circle trig problem, okay? All right, see if you can see on this next problem. What's the first thing you would do to make this a lot easier? M. Nelson. What do you think we would do first on this? Example 1. Yes. I'm going to let u equal x over 2. And then I'm just going to put a u right here. And then that seems like a pretty easy circle trig question. Interesting. I have 2 kids that left at the same time. Elise, can you hear me? Takara, can you hear me? Oh, I think I know what happened. I think my mic died. And they're all leaving because they're like, I can't hear anything. Testing, testing, 1, 2, 3. Elise, can you hear me now?
Yes.
All right, I think my mic died. That's why you guys couldn't hear me anymore. So I have just put on a new mic. I convinced them to give me a second backup mic for when that happens. So yay. Takara, can you hear me?
Yes.
Okay, excellent. All right. So we let u equal x over 2, and then we just go over and solve it like it was just a simple sine of u, or theta, equals 1/2. Sine's positive in the top 2. So then I'm here, and sine is opposite over hypotenuse. And it must be a 30 again. My gosh, the answer keeps on coming out to pi over 6. In this case, it's a bunch of pi over 6s, 5 pi over 6. Can I stop? No, because I now know that u equals pi over 6 and u equals 5 pi over 6. Everybody, think about what the next step is right here. Takara, what do I swap out now? Yep, with?
X over 2.
All right, so now I have x over 2 is equal to pi over 6. How do I finish that, Takara?
Multiply by 2.
Yep. 2 pi over 6, which yes can be reduced to pi over 3. Raise your hand if you had that one right. Sweet. On the other side, again, I swap it out for x over 2 equals 5 pi over 6 times by 2 on both sides. 10 pi over 6, which yes can be reduced. 5 pi over 3. I hope that one went a lot better than the last one. Okay. Let's try one with tangent then. Why is it saying between 0 and 2 pi? Helena, why is it saying that? Yep. No negatives exactly. Okay. Myung Hai, get me started here. What do I do?
Take pi x over 3 and then change it to u.
Put that equal to u. So this is really tangent of u is equal to -1. Do you feel like this is one of those quadrantals or not, Myung Hai? I agree. Which quadrants do you feel like we are in? Column 1, 2, 3, and 4 this time.
2 and 4.
So you believe that we are not here and not here.
Yes.
I agree. So now I'm going to draw it. And the sides are 1 and 1. Oh, 1, 1. That's easy. Root 2. And then I know what quadrant I'm in. And I know what angle I've got. It's pi over 4s. It's a bunch of pi over 4s. It's how many?
3 pi over 4.
And the last answer?
7 pi over 4.
Nice. Can I stop there?
No.
No. Jack Sand. U equals 3 pi over 4. Take it from there.
Multiply by 3 pi over 3 over pi x.
How about you just tell me to replace something with
Oh, yeah, just replace u with pi x over 3.
pi x over 3 equals 3 pi over 4. And then you can tell me that other thing. How am I going to get x alone?
Multiply by the reciprocal.
So what over what?
3 over pi.
Multiplying by 3 over pi. That's a very efficient way to do that. Nice job. Cancels, cancels, and I have x alone, and I have 9 pi over 4 pi, but then the pi's will cancel. Put your hand up if you had 9 over 4 before I said it. Nice. All right. Let's get some closure and finish the last one. Elise Breton, can you tell me how to do this right side? Replace the u with what?
You would replace it with pi times x over 3,
Keep going.
and then multiply both sides by 3 over pi, and then that would come out to 21 over 4.
You got it. 2 answers. 9 over 4, 21 over 4. Got a question? Not a question. Okay. All right. So that's what it's like. Now, again, I've noticed a drop off. Not all of you. Some of you are still rocking the house with 100% here and there. But there's been more kids that need to take retakes and stuff. Just a quick reminder how that's going to work. Tomorrow after school, you can come and talk to me and do corrections. I did do some in your class already, so you should have done most of the corrections there. But you can do corrections tomorrow after school. Then you could take the retake itself on Wednesday would be the ideal world. Then you're all caught up. You can put it off if you want to. Thursday after school is another option. Okay? So, what I think we should do for the rest of the hour, I think you should go on here. And usually what happened, just so you know past history, the reason there's some of these are circled and some aren't, is that the teacher was trying to cut down the assignment size. I had advocated for that, and I was saying, kids aren't going to do all of the problems. They're going to lose their mind, so we got to make it smaller so it's doable. And so he started circling the best ones. Okay, so he circled the ones that he knew were going to be things that are possibly on the test, not incredibly complicated, kind of the good meaty normal problems. So if you look for ones that are circled, those are probably good ones. All right, so practice. I know it's hard to motivate yourself if you don't have to, but if you're getting good results, keep getting what you're getting. You know, keep doing what you're doing, you'll keep getting what you're getting. If you've been getting low scores, that's the moment to try to put the two together and go, dang, I'm not getting a very good grade. Maybe I should change something. Maybe I should increase how much homework I do. All right, that's all I have for you for today. Remember to check the answer key when you're done, because it is posted.